Hello mathematicians, we're now going to have a look at an important function, the absolute value function. Absolute value of a number is simply its magnitude, so we ignore essentially ignore its sign. So for example, the absolute value of plus 10, and we write absolute value with these two vertical bars, is just 10, so no sign. And the absolute value of negative 10 is also 10. So this is the algebraic definition of that process. If x is positive, in other words x is greater than or equal to 0, then the absolute value of x is just equal to x. If x is negative, in other words x less than 0, then the absolute value of x is negative x. So if we look at that with respect to these examples here, we have that the absolute value of 5 is 5. 7 minus 4 we know is 3, and the absolute value of 3 is 3. 14 minus 9 minus 12 is negative 7, but the absolute value of negative 7 is just 7. And 3 squared minus 5 squared is 9 minus 25, which is minus 16. The absolute value of minus 16 is just 16. It's often useful also when we're solving simple equations and inequations involving absolute value to think of absolute value as a distance on the number line. So if we thought about absolute value of x equaling 10, what it means is that x is any point which is 10 units away from the origin. So that would be either plus 10 or minus 10. And we can then expand this concept to the case where we've got an expression like this, the absolute value of x minus a. And it's the distance between 2 points, x and a. So solutions to an equation like absolute value of x plus 3 equals 4 involves finding the 2 points which are 4 units away from plus 3. So the two possibilities there, so if this is plus 3, we can be 4 units away this way to give us plus 7, or 4 units away this way to give us minus 1. Again, purely algebraically, absolute value of x plus 3 equals 4 can be solved by taking this and realising that that could equal plus 4, or taking this in here and realising it could be equal to minus 4. So we have to solve both cases. And again, when we solve each of these, we get 7 or negative 1. So it helps to have more than one way of looking at these. So let's have a look at these equations. So our first one, mod of x, I'll keep switching between mod and absolute value because they're both equivalent terms. In extension 2, we tend to use the word mod. So mod of x, or absolute value of x equals 1, implies that this thing in here, if it is positive, it would just be 1. And if this in here was negative, it would be negative 1, in other words, just 1. So really we're saying mod of x, the x in there, could equal either plus 1 or minus 1. For our next one, mod of 4x equals 8, then either 4x equals 8, so therefore x equals 2, or 4x equals minus 8, therefore x equals minus 2. I'm not going to graph these on a number line just because I would just be putting closed circles. This one I might, so mod of x less than 2, then that means that either this thing in here is a positive, and we'd say x is less than 2, or that thing there in there is a negative, and in that case, that would mean that x is greater than negative 2. Now, I want to talk about this a little bit. So that comes about from our definition of absolute value up above, where we said we should look at two cases. So if x is greater than 0, then what's in here is we just take the positive value. So that means that x in there has to be less than 2. Or if x is less than 0, that should have been greater than or equal to, I suppose. If if we're talking negative numbers, if x is less than 0, then what we would do to in here is take minus of the value of x. So that would give us minus x is less than 2. When we divide through by -1, that will give us x is greater than -2. Then, if we look at this combination of statements, if x is less than 2 but it's greater than -2, then logically that goes together in this form. -2 is less than x is less than 2. And it's this region on the number plane. Here's our origin, here's 2, and here's -2. Now that is possibly, for some, more easily understood by our definition of mod as a distance. Because what this is saying is that the distance from the origin to x, or from x to the origin, doesn't matter too much how we think about distance, is less than 2 units. So that means anywhere out to +2 or anywhere out to -2 would satisfy. And if we were plotting it on the number line, we'd have open circles there and the solid line in between. Okay, now the next bit follows the same way, except we'll do the compacted version. So once we know that this is how this less than works, then it's okay for us to just write down straight off that this means -6 is less than or equal to 2x is less than or equal to 6. That's the way this less than or equal to works. So we solve that by dividing through by the 2, so -3 less than or equal to x less than or equal to 3. What we haven't mentioned so far, which will become more important later on, but which is worth checking now, is to test whether our answers are logical or not. So if we took, for example, -1, something between -3 and +3, if I put -1 into there, that 2x will become -2. The absolute value of -2 is 2, and 2 is less than or equal to 6. So it all checks out. So this is a summary of what we set up above, written in Maths Talk. So if function of mod x equals a, the solutions are that f of x equals a or f of x equals -a. If the mod of f of x is less than a, then the solutions are given by -a less than f of x less than a. So that was the case we looked at a moment ago. And we haven't looked at one of these yet, but if the mod of f of x is greater than a, our solution is given by these two statements. Now that is most easily understood, I think, by the distance concept. So if mod of f of x is greater than a, it's saying that the distance from to x or from x to the origin has to be bigger than a. So if a is out here, -a is out here, we want the points which are beyond that, because that will give a bigger distance than a back to the origin, or that are beyond that. Okay, so let's have a look at these examples. So our first example, mod of x minus 4 equals 1. So that means that what's in the mod signs, x minus 4, could equal +1, or what's in the mod signs, if we took the negative of it, could equal +1. But rather than do that, we generally say that what's in the mod sign could equal -1. So equivalent statements. So we solve this, so that gives us x equals 5. This one gives us x equals 3. But at this stage, when it's something more complicated than the ones we did up above, we really should check these to make sure that they're valid answers. So if I put 5 into here, 5 minus 4 is 1, mod of 1 is 1, so that's okay. I put 3 in, 3 minus 4 is -1, but mod of -1 is also 1, so that checks out. For our next example, mod of x plus 2 equals 2, it could either be that, or it could be that. Keep solving these, so this will give us that x equals 0, This one will give us that x equals -4. Again, check them out. If I put 0 into there, all good. If I put -4 into there, I'll get mod of -2, which is 2, so all good. Now this one here, mod of x minus 2 is less than 3. So we can write straight down that that means -3 is less than x minus 2, which is less than 3. If I add 2 to both sides, that will give me -1 less than x less than 5. And just to be sure, take a value within there. So take 0, it's a nice easy number. 0 minus 2 is -2, mod of -2 is 2, which is less than 3, so good. This one, mod of x plus 3 is greater than 4, using our idea of the distance up here, is going to mean that x plus 3 is greater than 4, or x plus 3 is less than -4, to make it more than 4 units away. So if I solve this, this will give me x greater than 1, and this one will give me x less than -7. I should have said, when I'm talking about 4 units away, I'm talking about 4 units away from +3 in this case. So if x is greater than 1, does that make sense? So if I put a number bigger than 1 into here, like 2 plus 3, when we take the mod of it, it is bigger than 4. If I put a number less than -7, so like -8 into here, that will give me -5. Mod of -5 is greater than 4. So again, all okay. Now the fact that as we saw up above, we can express absolute value in terms of cases means that we could write this sort of thing, that mod of x equals x for x greater than or equal to 0, and it equals -x for x less than 0. And this gives us an easy way to work out what the graph of y equals mod x looks like. So when x is greater than or equal to 0, it's the line y equals x, and when it's less than 0, it's the line y equals -x, which gives us this V shape, and the center of the V is on the origin. Now if we recognize that as what a mod curve looks like, then all the transformations that we've looked at before apply. So we'll have a look at these examples here. So if we were going to sketch y equals minus mod of x, we know the effect of a minus is to reflect in the x-axis. So if mod of x is up here, I'll draw it in green first, this is where mod of x is, then minus mod of x, I'll just change color, minus mod of x is going to be that curve reflected in the axis here. And for what it's worth, the equation of this line will now be y equals -x, and the equation of this one will now be y equals +x over those domains. Now y equals mod of x plus 2, we know the effect of the +2 is just to shift it up the axis. So we have our V shape here. The point of our V is at 2, and again, for what it's worth, the equation of this line is y equals x plus 2, because its y-intercept is 2, and this is y equals -x plus 2. For this one here, y equals mod of x plus 2, again, same rules, that this causes the graph to shift to the left by 2 places. So our graph looks like this. This is our point 2. And this point here, we just find the intersection of y equals x plus 2 with that axis, which would be 2. And this line here is going to be y equals -x and -2, because it would come down here and cut at -2. This curve, y equals mod of 3x, is just going to be centered with its v just here, and it will be simply steeper. So this line is then the line, y equals 3x, and this is y equals -3x. So you can think of other transformations there. Notice that I haven't taken y equals mod of minus x, because that would just, we know that the effect of that is technically to flip it in the y-axis, but then it would look exactly the same, which is y mod of minus x equals mod of x. So just worth noting that little bit. And of course we can have all sorts of combinations of these. So we could shift the v left, right, up, down, all in the same transformation, or flip it in the x-axis. Here are a couple of interesting ones to think about. So this one, mod of x squared minus 2x minus 8. If we graph the curve which is not the mod, so if we just graph y equals x squared minus 2x minus 8, then we know it's a quadratic. We look for two numbers that multiply to negative 8, add to negative 2, so that could be negative 4 and plus 2, which tells us we're talking about a parabola which is concave up. It's cutting at plus 4 and minus 2. We could get the axis of symmetry and the vertex. We won't bother for the moment. We can get where we cut the y-axis, because if we put x equals 0, that's just negative 8. And we know it's going to dip down. It's a terrible parabola. It's going to dip down further than that. So if we take the absolute value, remember what that absolute value actually means. Absolute value says that where the value of this thing in here is positive, we just leave it like that. So where is that positive? Well, it's on this part of the curve, where the y values are positive. So we just leave them like that. And where the y values, so the values of x squared minus 2x minus 8 are negative, which is down here, those negative values get transformed into positive values, which means that this part of the curve here simply gets reflected in the axis. That bit and that bit are supposed to look the same, obviously, but that's all we do for those sorts of curves. Anything below the axis we reflect above the axis. Now this next one is quite a difficult example. So we need to get our head around what happens with these absolute values. So if we think about this one here to begin with, if what's in the brackets here is positive, so in other words, if x minus 2 is positive, then we know that we just take it as x minus 2. So that occurs if, for x minus 2 to be positive, that will happen when x is greater than or equal to 2. And if what's in the brackets in here is negative, we know we take negative of what's in the brackets. So that happens if x is less than 2. If we move on to this one, again, if what's in there is positive, then we just take it as is. And that occurs if x plus 4 is positive, which means x is greater than or equal to negative 4. And if what's in the brackets in the absolute value signs is negative, we take the negative of it. And that happens if x is less than negative 4. So there's something that happens over this range here. And really we've got three possibilities to work with. So if x is greater than if x is greater than or equal to 2, we take x minus 2 as our value of this bracket. And for this one here, if we are greater than or equal to 2, then we're certainly greater than or equal to minus 4. So we take x plus 4 for that one, and a 1. So that gives us that y equals, so x minus x, so the x's are gone, minus 2 minus 4, which is minus 6 plus 1, which is minus 5. Now, if x is greater than or equal to minus 4, but less than 2, so if minus 4 is less than or equal to x, which is less than 2, then we're going to take x plus 4. Oops. Sorry. So we're going to take minus of x minus 2, and we're going to take x plus 4, and we've got our 1 there, so that'll be minus x, and minus 2x, minus 2 is plus 2, minus 4 is, plus 2 minus 4 is minus 2, minus 2, plus 1 is minus 1, and finally, our last case, if x is actually less than negative 4, then y will become minus of x minus 2, because if it's less than minus 4, it's definitely less than 2, minus of x plus 4, so that'll become that, plus 1, which is then going to equal minus x and plus x. The x's are gone. That will be plus 2, plus 4, plus 1, so that's 7. So running out of space here, but that will look like, so when x is greater than or equal to 2, so here's 2, then y has to equal minus 5, so down here somewhere, and it just goes on. When x is less than negative 4, so here's negative 4, we want it to equal 7, so that way, so this is minus 5, that's 7, and in between we want it to be minus 2x minus 1, which is a line which cuts through at minus 1 and has a slope of minus 2. Pretend that that's a straight line there, so it looks something like that. Okay, as I said, really hard example. I'm 99% confident you won't get anything like that. So finally, just to finish up on a few further identities of the absolute function which may prove useful, possibly more to people who are going to do extension 2 at some stage. Have this one, which is pretty good to get your head around, and which will be sort of common in extension 2, that the square of the mod of x is just equal to x squared. You can figure that out. If that's always just going to work out to be x, then we're just going to square it. Maybe a little bit less obvious that the mod of x is equal to the positive square root of x squared, because again, the mod of x is always going to come out to be the positive bit. This one here, x minus y, mod of x minus y is mod of y minus x, probably makes most sense from the perspective of distance. The distance from x to y is the same as from y to x. This one, mod of xy equals mod of x times mod of y. You can just see that we're dropping signs off, so that should make sense. And mod of x over y is mod of x divided by mod of y. So have a go at the examples now, and just keep returning to what mod actually means to get you through.